Let's talk about the effect of temperature on solubility. Okay, first of all, the three blue questions. Number one, what do you observe? This is after you've put the 5 grams of each solid in 5 cubic centimeters of each liquid and heated it. So we're going to say K2NO3 dissolves completely. It turned into a clear liquid after we heated it. Salt didn't do anything. It stayed pretty much the same. The next question, do the solubilities of substances appear to change equally or differently as the temperature of the water is increased? They change differently. And number 3, what do you predict will happen if you remove the burner and cool both test tubes together in a beaker of cool water or cold water? What happens is K2NO3 comes back. It doesn't stay completely dissolved any longer. Let's flip over to the numbered questions here. And we'll have to kind of flip back and forth as we look at some of the figures. And I'm going to erase this. But number 13 says examine figure 4.3. At what temperature are the solubilities of potassium nitrate and sodium chloride equal? So here's figure 4.3 right over here. The temperature at which they're equal at is the temperature at which their lines cross, which is right here. That's at about 25 degrees Celsius. So number 13 is 25 degrees Celsius. Number 14, how many grams of sodium chloride can be dissolved in 100 cubic centimeters of water at room temperature, which is about 20, and at 100. So at room temperature, 20 degrees Celsius, we just move it up to intersect the yellow line, and I would say it's about halfway at 20 degrees Celsius, maybe a little bit over half. We'll say it's about 36 grams. And then if we go all the way over here to 100, it goes all the way up to 40. So we're going to say $36 grams, and then for this one, 40 grams. Number 15, suppose you have a saturated solution of potassium sulfate at room temperature from figure 4.2. What do you predict will happen if you heat the solution? So this is figure 4.2 right here. If it's saturated at room temperature, which is 20 degrees. So at 20 degrees, if we heat it up, let's say you've got exactly 100 grams. That means you've got 11 grams in 100 cubic centimeters of water. If we heat it up, the solubility becomes greater than that. And so it becomes unsaturated. So we're going to say for letter A on number 15, and I'm going to go ahead and erase these. If you heat the solution, it becomes unsaturated. If you cool the solution, so let me flip it back again. At 20 degrees you have 11, but if you cool it, let's say you just cool it to 10, which is all we have on here, the solubility goes down to 9. And so you're going to become supersaturated. We're not really going to talk about things in terms of being supersaturated. We're just going to say what's going to happen is a precipitate is going to start to form. So you're going to pass the point of saturation to the point that it's oversaturated, and you're going to get solid forming at the bottom. So I'm going to say precipitate begins to form. Number 16, if you plot the data from figure 4.2 on figure 4.3, where would the curve be found? Well, let's just do it. So if we take this data here and plot it on this graph here, let's see what it would be. So let's just take, it's pretty much a straight line. 10 degrees is about a solubility of 9, and 90 degrees is a solubility of about 23. So at 10 degrees, if we put a dot there at 9, and at 90 degrees, if we put a dot at 23, and I'm not going to be able to draw a straight line here, but you'll just have to bear with me. So that data would be at the very bottom of this graph here. So that's what we're going to say on number 16. They say, where would it be found? I'm just going to say at the bottom of figure 4.3. Number 17, give a reason for heating the solutions in experiment 4.4 by immersing the test tubes in a beaker of hot water rather than heating the test tubes directly over a burner flame. The biggest reason is it's easier to control the temp in a beaker. Number 18, what temperature is required to dissolve 110 grams of sodium nitrate in 100 cubic centimeters of water? So let's look at this graph again. And let's just find 110 grams and see where it intersects the line. It intersects it right here. Sodium nitrate's the pink line, right there at about 45 degrees Celsius. So I'm going to erase this. And the answer to 18, I'll put it up here, is 45 degrees Celsius. Number 19, we've got A and B. 19 says if 20 grams of sodium chloride is dissolved in 100 cubic centimeters of water at 20 degrees Celsius, is the solution saturated? So if we find 20 grams at 20 degrees Celsius, that's right here. This line is a saturation point for sodium chloride. It's below the line, so it's not saturated. So we're just going to say on letter A, no. If you're at the line exactly or above the line, it's a saturated solution. If it's below the line, it's an unsaturated solution. So now let's look at B. B says, how do you determine whether a solution is saturated? So we just answer that. At the line or above is a saturated solution. Number 20. I'm going to have to move this over a little bit. A mass of 30 grams of potassium nitrate is dissolved in 100 cubic centimeters of water at 20 degrees Celsius. The solution is then heated to 100. How many more grams of potassium nitrate must be added to saturate the solution? So we have 30 grams at 20 degrees Celsius. So 30 grams at 20 degrees Celsius, that's pretty close to being a saturated solution. If we leave the same 30 grams in there, we heat it up to 100 degrees Celsius, you can now hold this much, about 240. So we've already got 30 in there, so 240 minus 30 is 210 grams. It would take 210 more grams to make a saturated solution. And then the last one, number 21. A mass of 10 grams of sodium nitrate is dissolved in 10 cubic centimeters of water. If we scale that up, that's 100 grams in 100 cubic centimeters of water, because that's what we want it in. So the units are the same. At 80 degrees Celsius, as the solution is cooled, at what temperature will a precipitate first appear? So 100 grams at 100 cubic centimeters. at 80 degrees Celsius. So 100 grams, 100 cubic centimeters at 80 degrees Celsius is about right here. We want to know the temperature at which the precipitate first starts to appear. That's going to be the temperature at which we hit this red line or this pink line. So right there, at about 35 degrees Celsius, we're going to start to have a precipitate start to form. So 35 degrees Celsius. Remember, a precipitate is just the solid coming out of solution.